All right, we're on section 12.2, completing the square, and this section actually does not have an exclamation point, but I put it there because I like to complete the square. And the general idea is that, remember, we're solving quadratic equations. Okay, so solving quadratic equations, that's our goal. And there's different ways to do it. So let me go back to where we were yesterday for a second here. Yesterday, we talked about the different methods to solve a quadratic equation. And on your homework, you had some perfect squares where you could just take the square root of both sides to solve. The second method is to factor, which is always a very easy, usually very easy way to solve them, but they're not always factorable. The third way is to complete the square, and what we didn't say is this method always works also. For some people, it feels like it's the hardest method. I don't think so, but anyway, completing the square and quadratic formula will work every time. So we're on completing the square. All right, so back to this. Now the idea is that we're gonna make a perfect square. And if you remember, the middle term is a times b doubled. You'd have to, that's how you do that little check where you see if that middle term works out. We're gonna create this so that we can then write the factored form of a perfect square. And let me show you through example. We're gonna solve x squared minus 3x minus 18 equals 0. And it's quadratic because the highest exponent is a 2. Now, this looks like we could factor it to solve. Yeah, actually this does factor, but let's say we couldn't factor. This is still a good way to illustrate the method. So the first step is to take the number and toss it to the other side. So let's say step 1, move number to right side. All right, so we're going to, I'm going to slide this over a little bit. X squared minus 3x. Now when you do this, leave space. See, I have just the x terms on the left side now. Leave some space here, put the equal sign, and now I have 18 here. So leave, I won't write anything there. Now, I could explain why we're gonna do this, and I'm afraid it's just gonna maybe get too confusing. So let's keep it easy. We're just gonna take this -3, well, here. Let's do this first. Put plus something squared on both sides. So that's step 2. Add something squared. We're gonna be putting something in the something. Add something squared to both sides. So what we're doing is we're adding something that's not there in the equation to force this situation. And remember that an equation, as long as you add the same thing to both sides, you haven't changed the balance. You haven't offset it. It's still equal. Now what goes in this parenthesis is going to be half of this number. Don't use any decimals. The best thing to do, you're just going to put this, basically we're going to put this, or put a 2 under it. That's what goes in here. -3 halves. And we're going to put that same thing here, -3 halves. So I'm adding the same thing to both sides. So let's say this is half of the -3. And notice I kept the sign with it. So anyway, just if that's a negative or if that's subtraction, keep the sign. What I've created here is a perfect square. So let's say step 3. Put half of middle number in the parentheses squared. All right, so we've created a perfect square. So now I'm going to go down here and write it like this. Because remember, we created this so that we can then make it factored in perfect square form. So this is going to be x. That's a -3/2 right there. So I'm taking the minus and the 3/2 and putting it in the parenthesis. Now on the right side, we just need to do the math, basically. So step 4. Factor the perfect square on the left. That's what we did here. And do the math on the right. Now, some of you aren't going to like these fractions, but trust me, you want to keep this in a fraction. You want to keep this as a fraction, because if you start putting things in decimals, it's going to be harder to work with in the end. So I have 18 plus -3/2 squared is going to be +9/4. Right? That goes to that. Now, you might like this even less, but we need to get a common denominator of 4. So I need to get common, my dog is snoring, denominator. So I'm going to multiply this 18 by 4/4. And that's going to give me 72/4, right? 18 times 4 is 72, plus 9/4. X minus 3/2 squared. Okay, and we don't really need to continue the steps because this is just, basically this is like last section, except you have to do something here. All right, so 72 plus 9 is 81/4. See, that actually is a nice number for square root, that is. And then we have the x minus 3/2 squared. Now what you would do, because we have a square term by itself, I can take the square root of both sides and I'm going to put a plus minus. Let me get my highlighters. Don't forget the plus minus. Okay, and then we just have to solve this. So x minus 3/2 is what you get when you take the square root of the square, equals positive and negative. Now the square root of 81/4 is 9/2. You take the square root of the top and the square root of the bottom. I'm going to move the -3/2 over. So I get x equals, I'm putting it in the front so that I have the plus minus in the middle. And we've got this weird looking thing. that is just two numbers. So 3/2 plus 9/2 is 12/2, which is 6. So I have a 6, and then 3/2 minus 9/2. Well, 3 minus 9 is -6/2, so -3 would be the other answer. And there it is. Now, something you might find annoying is if I go back to my original problem, if I factored it, I could have solved this. X squared minus 3x minus 18 equals 0. I could have just factored this. X, 3 times 6 is 18. I need to equal -3 minus plus. So -3 would make that one 0. 6 would make that one 0. And there we go. So anyway, you could use this method, but they don't always factor. And so sometimes you might want to use this method.